Hello, everyone. Good morning. Thank you to everyone for joining today's webinar series. We're going to go ahead and get started on doing more with SSL Decryption. A quick overview of what to expect in the next 60 minutes. In the next 60 minutes, we'll be covering the following: SSL Decryption Overview, Plan SSL Decryption Deployment, which will cover certificate management and SSL forward proxy, deploy SSL decryption using best practices, follow post-deployment best practices, and of course, a quick reminder to everyone of our upcoming webinar, which will be next week, doing more with Prisma Access, best practices for logging and reporting, which will be happening next Wednesday, September 15 at 8 a.m. Pacific time. So just wanted to let you know your Prisma Access Customer Success tour guides for today are the following. As your Prisma Access Customer Success managers, we have myself, Wendy, and Anil. Prisma Access Customer Success engineer today is Karam Shasad. And also wanted to remind everybody that if you wanted to access any of the documents that you will be seeing on today, you can access those on Tech Docs, also live community. And also wanted to let everybody know as well that a quick reminder that if you have any questions, please feel free to enter those questions on the Q&A box and we'll make sure to address those questions. I'm going to go ahead and hand it over to my colleague, Karam, who will be covering the following.
Thank you, Wendy. Hello, everyone. Good morning, good afternoon. Welcome to another session on SSL Decryption. Let's have a look into the decryption, and then we will go to the SSL Decryption as per the agenda. If you have any questions in between, please feel free to post in the Q&A, and we will answer all of your questions at the end of the session. Decryption Overview. Each year, now more web traffic is encrypted. So Prisma Access provides the capability to decrypt and inspect network traffic for visibility, control, granular security. Decryption on Palo Alto Networks devices includes the capability to enforce security policy on decrypted traffic, where otherwise the encrypted traffic might not be blocked, and shaped according to your configured security settings. Use decryption on a firewall, and on next-gen firewall or a Prisma Access to prevent malicious content from entering your network or to prevent sensitive content from leaving your network concealed as encrypted traffic. Prisma Access can decrypt and inspect traffic to provide you visibility, and this decryption can enforce policies on the encrypted traffic. This decryption is policy-based and can decrypt, inspect, control inbound and outbound SSL and SSH connection. A decryption policy enables you to specify traffic to decrypted by destination, source, service, or a URL category, and block, restrict, or forward the specific traffic according to the security settings in the associated decryption profile. Why we need decryption? Decryption the traffic will help to prevent malware concealed as encrypted traffic from being introduced into your network. For example, an attacker compromises a website that uses SSL encryption. Employees visit that website and unknowingly download an exploit or malware. The malware then uses the infected employee endpoint to move laterally through the network and compromise other systems. It will prevent sensitive information from moving outside of your network. It will ensure the appropriate applications are running on a secure network. Selectively decrypt traffic. For example, you can create a decryption policy and profile to exclude traffic for financials or healthcare or any of your compliance or regulatory requirement. So this is basically a strategy for the advanced threat prevention. Advanced attacks are not random events. They are highly organized campaigns that leverage multiple techniques operating simultaneously over long periods of time. The longer you take to detect how and where compromise took place, the longer attackers have to expand their footprint into the new environment and exfiltrate the key information. So, 5 imperative strategies for the advanced threat management. The first and foremost is achieve complete visibility for all the traffic, regardless of port, protocol, or encryption. Limit the control traffic entering to your network, reduce the amount of traffic that needs to be analyzed for 0 days or APTs. You can block down the threats with signatures, take automated actions, and create a closed loop for the protection. And for the full visibility of the traffic, decryption is one of the most important factors which will give you the visibility into the traffic, regardless of port, protocol, or what is the encryption they're using. Let's have a look at some key concepts of SSL encryption. And the two broad categories of encryption algorithms are symmetric and asymmetric. Asymmetric key encryption, which is also known as the public key encryption, uses two different keys for encryption and decryption. Data encrypted with one key can be decrypted only by the other key in the pair. And the advantage of this asymmetric encryption is that it allows for a secure transfer of information between the parties that have no pre-existing communication. With symmetric key encryption, which is also called the pre-shared secret key, uses a single key to encrypt and decrypt the messages. And the greatest disadvantage of this method is that the key must be known to both the parties before any secure communication can be used. The key must be exchanged through an existing secure channel, and this limitation makes any kind of spontaneous exchange difficult to achieve. SSL represents a protocol for encryption, an HTTP connection between the client and the server, where no pre-existing secure channel is present. SSL takes advantage of the strength of the symmetric and asymmetric encryption schemes. You can see that here the SSL session flows like a client requests an SSL connection, the server responds with SSL certificate, the client validates that server certificate, and if the certificate is valid, the client uses the key to encrypt. And number 5, you see that at that point, both sides of the communication have the same symmetric key and can begin sending the bulk data over their new secure channel periodically. Decryption policies. Prisma Access can be configured to decrypt SSL and SSH traffic going to external sites. With the SSH option, you can selectively decrypt outbound and inbound SSH traffic to ensure that secure protocols are not being used to tunnel disallowed application and content. You can also apply decryption profiles to your policies to block and control various aspects of the SSL traffic. Let's assume a scenario where a user will connect via an encrypted connection to the Facebook. The company policy is to allow all employees to read the Facebook but prevent the Facebook chat or prevent the Facebook postings. So if SSL decryption is enabled for the Facebook application, this limitation can be accomplished easily with the Prisma Access using SSL decryption. If SSL decryption is not enabled, then the Prisma Access cannot identify which application is inside the SSL connection, nor it can recognize the application shifts are occurring within that connection. Plan SSL decryption deployment. How you can plan, what are the key components you should consider? So here are the steps, and I will go to each and every steps. First of all, you need to set your goals. Develop a decryption deployment strategy, then a plan for the PKI rollout, public key infrastructure, assess the available resources and the performance impacts, and the plan is stacked of the prioritized deployment. The most time-consuming part of deploying a decryption is not configuring the decryption policies and profiles. It's preparing for the deployment by working with the stakeholders to decide what traffic to decrypt and what not to decrypt. Educating your user population about changes to website access, developing a private key infrastructure, PKI strategy, and then planning a stats, prioritize the rollout. So you need to set up goals for the decryption to review the decryption planning. Let's have a look into each of the steps and what are the key prerequisites and you should consider. Set goals. You need to plan to decrypt as much traffic that is not private or sensitive as your to the Prisma access to allow to reduce the attack surface by exposing and preventing encrypted threats. First of all, you need to understand your local laws and regulation about the traffic you can legally decrypt and user notification requirements. Migrate from port-based application to port-based policies to application-based policies before you create and deploy decryption policy rules. If you create a decryption rule based on port-based security policy and then migrate to application security policy, the change could cause decryption rules to block traffic that you intend to allow because security policy rules are likely to use application default ports to prevent application traffic from using non-standard ports. For example, traffic identified as a web browsing application on the default port 80 may have underlying application that have different default ports, such as maybe HTTPS or like the default port of 443. The application default rule blocks the HTTPS traffic because it sees the decrypted traffic using a non-standard port. Step number 2, develop a decryption deployment strategy. You should work and educate stakeholders such as your legal team, your finance, HR executives, security team, IT support, and develop a decryption deployment strategy. Get the required approvals to decrypt traffic, to secure your corporation, identify and prioritize the traffic to decrypt, and decide which applications to decrypt. Decide if you want the same decryption policy for the different users group, and also identify the traffic which you can't decrypt. Then prepare an updated legal HR computer users policy and distribute to all employees. And also decide how to handle the certificate verification. Your business model may require trade-offs between the security and the user experience. So understanding how you want to handle certificate verification helps determine how you configure SSL decryption profiles. Identify and prioritize the traffic decrypt. You can create a report to review the URL categories and the application you used. You can generate this report from your panorama, this custom report, and you can use these filters and see what are your URL categories mostly and where you can implement this SSL decryption rules. Develop a plan for the rolling out your PKI infrastructure. So if you have an existing PKI, generate the SSL forward trust CA certificate from your enterprise root CA as subordinate certificates. This makes the deployment easier because the network devices already trust the enterprise root CA and you won't run into certificate issues. So if you don't have any enterprise root CA, You can consider getting the alternatively, or you can generate a self-signed root CA certificate on your panorama, which will be using for the Prisma access, and create the subordinate forward trust CA. Similarly, you can for the bring your own device policy. If you have BYOD devices, enterprise don't control those guest devices, and you allow the guest devices on your network decrypt their traffic and subject it to the same security policy that you apply to the other network traffic. There are some factors which may affect how much traffic you want. You can decrypt, which includes the amount of the SSL decryption traffic, key size, key exchange, certificate authentication versus the RSA and encryption algorithm. These are the key important factors you should consider when you are planning for the SSL decryption deployment. Look for all those information in your network, what are certificate authentications, key exchange algorithms you are using, the key size, and the protocol. Identify the early adopters in your planning to champion that decryption and get each department or the team's managers on board with the plan. You can set up a POC or the testing in each department to test the deployment strategy before you roll out to the general user population. Made the way of decryption POC and also educate the testing phase or the POC participants on the changes and how to contact the technical support team if they have any issues while you have implemented a test phase. Certificate management. A public key infrastructure PKI certificate is a method of packaging and distributing the asymmetric keys. It is basically a key package with information about the nature of the key and is signed with a digital signature by the authority who have issued the key. So this is how the certificates examples here. You can rely on a certificate and the information. And the public key contains when the issuing CA is trusted and the signature hash value in a certificate is valid. An issuing CA computes the hash value of a critical information in a certificate and includes that hash value in that certificate. To prevent the tampering of the hash value and the other critical information certificate, the issuing CA encrypts the information with its own private key, and the receiving entity uses the issuing's public key to decrypt that information. If the certificate of its issuing CA is not added to the client's certificate store, client receives a certificate warning message when browsing to secure websites verified by that CA. So you can see here the chain of trust. The certificate chain of trust is a list of certificates used to authenticate a server to the other entity. This chain begins with the server certificates. Each certificate in the chain is signed by the entity identified by the next certificate to the chain. And for example, if we are accessing the SSL server on the Microsoft site, Microsoft.com, the Microsoft SSL server will present us with a certificate that authenticated its identity. That certificate has been issued by an authority called Microsoft Internet Authority. Our browser looks up the certificate for that intermediary authority and uses it to validate the signature on the SSL server certificate. The browser can then check to determine which authority issued the intermediary certificate, retrieves the key from that higher authority, and verify the certificate. This process continues until a root CA is encountered in the chain. And a root certificate is a self-signed certificate because the issuing authority is itself. These root CA are from the basis of all PKI deployments. So self-signed versus CA-issued certificates is kind of a differentiation between those two. For any part of the PKI to work, there must be a reliable way of getting public keys. The private keys also must remain private. When a certificate is signed by its issuing authority, that signature is only reliable as the authority is trusted. And the self-signed certificate is free self-signed certificates created on a home PC of valid certificates, but they will not be recognized by the browsers because they are not issued by any well-known CA or certificate authority. Trusted root CA for the forward proxy. 3 different options for the forward trust CA certificates. Generate the certificates signing request via certificates pages, CSR. Upload the subordinate CA signed by the enterprise root. And the third option is self-signed certificates. Each of these certificates is authorized for different users. For example, a signing certificate is authorized to sign other certificates. You can obtain the initial certificate from a third-party CA. And the advantage of this choice is the third-party CA certificate is signed by a root CA, and all the end clients likely already will trust the root CA. And this root CA trust means that the end client also will trust the third-party CA. Trusted root certificates distribution. All the browsers, Chrome, Microsoft, and Safari, all the average operating system trusted the CA store. Trusted root certificates can be installed on the OS cert store using Microsoft AD, Profile Manager for the Apple Mac OS, or you can use the commercial tools like JAMF, open source tools, SaltStack, MDM, if you are using any mobile security manager, AirWatch, Mobile Iron. Let's have a look at the quick demo for the certificate management.
In this talk about certificates with Prisma Access. In the Prisma Access environment, when you onboard your mobile users, 2 certificates are created. The Authentication Cookie CA, which is a certificate authority, and the Authentication Cookie Certificate. This is used potentially with Global Protect mobile users on the portal as a means of authentication. The portal can issue a certificate for authentication to it. Because this is a CA certificate, a certificate authority certificate, to generate other certificates, like for your Global Protect clients, this certificate could also be used to put on your gateways and things like that. This is a signing CA. Now, in addition to these 2 certificates, you could also create your own. I'm going to click on Generate. When I do, this screen right here comes up. I've taken a minute to fill this in. I've labeled this as self-signed CA. I could give this a common name or a IP address listed here as the common name for this. I'm going to give it the common name of lab.local. Now, right here is where I want to focus on signed by and certificate authority. If I leave the signed by field blank, this is going to cause this to make a self-signed certificate. Because I have clicked certificate authority, this would create a self-signed CA certificate that I could use to sign other certificates. If I want to do this, it would mean that I would have to install this certificate to be a trusted root certificate to all of my mobile clients. That may not be desirable, but we'll just follow through on this and click on Generate. This has now created this self-signed certificate. What you probably want to do is I'm going to come back here to Generate again. And again, I'm going to fill this in. Now, I've taken just a minute to fill this in. I've said the certificate name is going to be Intermediate Certificate because I'm going to take this. I'm going to bring it to my root CA, and I'm going to get it signed there. By the fact that I have made this signed by an external certificate authority, it says CSR here, as opposed to creating a certificate within Panorama to be propagated to the Prisma Access Cloud. As opposed to doing that, this is going to create a CSR. I've checked certificate authority here to say that this is going to be a signing certificate, and now I'm again going to click on Generate. This has not created a certificate. You'll see it in yellow here. This has created a CSR. I would select this and then export this. Okay, I would select this and then export this. Downloading it out of Panorama onto my machine so I could bring this over to my root CA, get it signed, and then import the signed certificate and its key back into Panorama. By doing that, I would then have a certificate, a signing certificate within Panorama that would allow me to use the inherited authority of my company's root. That would save me from having to teach any clients that received certificates signed by this to trust it because they're already going to trust my company's root.
Thank you. So let's have a look into each steps involved here. So as you watch in the demo, log into your Panorama, go to the Device tab, Certificate Management, and you can generate the certificates here. And this certificate management interface provides you access to all the certificates that may be needed for the Prisma Access deployments or your next-gen firewall if you're using the same Panorama. Self-signed certificates can be created to forward Proxy SSL decryption or existing certificates. And keys can be loaded to forward proxy and inbound SSL decryption. The use of an existing CA ultimately simplifies the deployment of SSL decryption. And self-signed certificates can be generated easily using Web UI. All the fields of the certificates should be filled in. The name entered in the interface is the publisher name on all decrypted certificates. Certificate signing requests. Generate certificate signing request for external certificate signing. You can see here a key pair is created on the machine and exported that in the PKCS format. The administrator sends CSR to the CA, which generates the request certificate. When the resulting certificate is received from the CA, imported with the same name as the CSR. When the issued certificate is imported, the certificate signing request is removed and certificate will be added to the private key. You can see the certificates hierarchy in your device tab in the Panorama. Go to certificate management and click on the certificates, device certificates, and you will see all the certificates. To aid in the management of certificates, the PAN-OS software organizes the certificate listings as a tiered list. The format simplifies the process of determining which certificates are related by grouping certificates under the CA certificate. Let's now have a look into the SSL forward proxy. So Prisma Access is configured to decrypt the SSL traffic going to the external sites functions as a forward proxy. So in this scenario, the firewall intercepts the client SSL traffic, SSL certificates request. The firewall then, or the Prisma Access forward request to the server, but generate a certificate on demand in response to the client request. This resulting a secure connection between the client computer and the Prisma Access. The Prisma Access then initiates another secure channel to the actual server using the server certificate. This process allows Prisma Access to sit in the middle of these two secure connections. Be aware of these key points that when you are implemented the forward proxy, the validity date on the self-generated certificate is taken from the validity date on the real server certificates. The device acts as a proxy of the SSL connection, not the underlying traffic. Any packet capture PCAP functionality executes before the decryption. Prisma Access, all the devices, this supports the 2048-bit RSA keys for SSL inbound inspection sessions. For SSL forward proxy sessions between Prisma Access and the destination server, and for the SSL forward proxy sessions between the firewall and the client. Forward trust and forward untrust certificates. With the SSL forward proxy decryption, the firewall resides between the internal client and the outside servers. This Prisma Access devices forward the trust or forward the untrust certificate to establish itself as a trusted third party to the session between the client and the server. When the client initiates SSL session with the server, Prisma Access intercepts the server SSL request and forward that SSL request to the server. The server then sends a certificate intended for the client that is intercepted by the Prisma Access backend. So if the server certificate is signed by the CA that Prisma Access trust, the firewall creates a copy of that server certificate signed by the forward trust certificates and send the certificate to the client for authentication. Configure SSL forward proxy decryption. Configure the forward trust certificate using self-signed certificates or use certificates signed by an internal CA. You can also configure a forward untrust certificates, which can again be using a self-signed certificate, and create a decryption policy. Choose the URL categories to decrypt, and also it's an option, but I would recommend to create a decryption profile. So you can configure the forward trust certificates. Log in into your Panorama device tab, certificate management here, and the forward trust C is the certificate that signed the server certificate, as we have talked about earlier. So here you can check the forward trust. Make sure that you're checking this box and putting up all the information. So if you're clicking on this forward untrust certificate, so the client browser should not trust this CA, so that that a warning message disappear. Decryption profiles. Log into your panorama, go to the Objects tab in Decryption Profile, and you can see there the various applications the clients use that SSL encryption. When a web server communicates with the web browser via HTTPS, the SSL connection highly conform to the SSL RFC's standardization is important for ensuring the services are available to anyone on the internet with a web browser. Some users of SSL encryption may deviate enough from SSL standard such that they no longer work with decryption, the Palo Alto networks. Here is some of the information which is kind of a proprietary or for the non-standard encryption methods. You can use the decryption profile to enforce the use of strong cipher suites to decrypt traffic, which include specific enforce of B ciphers or AES 120 or GCMs. Enforce the use of minimum and maximum protocol versions. Also enforce certificate validation on per policy basis. And you can see all the check boxes here where you can select a different cipher suites, different options, and define different traffic that you want to decrypt using TCP port numbers, which enables you to apply different decryption policies to the traffic for a single server. Then this decryption profile then can be applied to the decryption policies to block any session that Prisma Access cannot decrypt. Decryption may fail if none of the cryptographic algorithms offered by the client and the server is supported here. Block any unsupported encryption. You can checkbox all these if you want to block any of the unsupported all the modes. For further granular control for the SSL protocols, you can select all of the SSL protocols, whatever you want to encrypt, minimum and maximum versions. Control for the SSL traffic that's not encrypted. The non-decrypt tab will enable you to administrator to block sessions to sites with the bad certificates without having decrypt the session traffic. And this settings takes away the option from the end user to ignore the bad certificate. Decryption profile recommendations take a strong stance against invalid untrusted certificates. So make sure that you're blocking all the sessions with expired certificates on the untrusted. Let's watch a quick demo for the decryption rule set before I go into the details.
In this demonstration, we'll take a look at the Prisma Access Decryption rule set. In order to access this, I'm on Policies, and then remember, the device group that's chosen is very important because this is where this actual decryption policy will exist. In this case, I'm creating this in my remote network device group. That would mean that security processing nodes associated with a remote network would get this particular policy. I have a decryption set of 4 rules right here. The most important takeaway from this conversation is probably that decryption is not an all or nothing policy, okay? Decryption is not all or nothing. So in my rule set, my first rule here, and I can't really see the name, so I'll go up here to the word name, and I'll click on Adjust Columns so that I can see all of the information across. In my first rule here, rule number 1, it says that users net to the internet, to this specific address, I'm not going to decrypt that traffic. So only traffic that is bound from the user's net to the internet zone, bound for this address, would match this rule and then not be decrypted. All other traffic would fall to the next rule. And do the criteria of this rule match the traffic, yes or no? And then it would take the action here. There are many different philosophies that you could follow in the creation of a decryption rule set. In my decryption rule set, what I've chosen to do is have targeted exceptions, 3 of them here, that I don't want to be decrypted. And then my last rule, my cleanup rule, rule number 4 here says that if you didn't match any of these first 3 exception examples, then I want to decrypt everything else. In my exception rules, I have made exceptions for certain users' traffic not to be decrypted, using user ID to do the matching. Here, I have a simple example and I've just used username, but you could also use LDAP or Active Directory group membership with a properly configured user ID environment. And then also by URL category, a very common way to implement controls over this. I also have made a specific exception of things that I don't want to be decrypted. And then everything else as it hits this rule here at the bottom would in fact be decrypted. I'm going to open up my decrypt all other rule now. It's got a name. I can specify source zone, source address, and source user for my pattern matching. I can specify destination zone and destination address. I can specify service, okay? Remember, service is not application. Service is generally matching on the destination port of where the traffic is headed to, and a very common way to control these things, URL category. On my Options tab, I can specify my action, specify the type of decryption rule this is, because it might be SSL forward proxy, SSH proxy, or SSL inbound inspection. That would be if I controlled the certificate, is where I would use the SSL inbound inspection. In my decryption profile, I can specify things about how certificate checking has occurred, whether or not I'm going to allow this through, and other more specific granular items. In this list, it's important to remember the rules are first fit scanning. The first one that you come to, where you've met all the criteria, it will take the action that you have specified here in the action column, and decryption is not an all or nothing proposition. You have pretty granular controls over what it is you want to attempt to decrypt and what it is you want to go through maintaining your user's privacy.
Thank you. So let's go into the each steps involved in creating decryption policy as we have watched the demo video. So go to the log into your panorama, go to the policies and decryption, and you will select the option there, decrypt or not to decrypt, and then what type of decryption you're using, SSL forward proxy or SSH proxy or SSL inbound. Then URL category, select the URL categories, create a policy which uses the URL filtering to decide which traffic to decrypt and not to decrypt. And a user ID or destination address can also be used to decryption decisions. But in practice, the decision usually is made on the URL filtering category of the destination address. Organizations may choose not to decrypt specific applications because they consider those destinations to be trusted and pose less risk, or the local laws and regulation may also restrict whether the specific type of traffic, such as the financial or the medical informations, are allowed to be decrypted. So you need a URL filtering license to use the URL filtering categories. Also, you can use use the custom categories also. Create a security policy rules. log into your policies, and you can create your security policy, create a rule to allow the SSL. So as we watched in the demo, to decrypt everything except the sensitive traffic. Apply the SSL control to undecrypted traffic via profile, and create exceptions rule for the specific destinations, IP, source, users, or the URLs. So these are the basically the key takeaways, recommendations, and also add reasons to bypass the rules. Discover any of the important application that breaks due to decryptions, or there are any additional site that uses sensitive information, any regulatory or compliance reasons. If there's a problem which you can fix that problem rather than just create an exceptions rule or bypassing the rule. So sensitive categories you can avoid always, as I mentioned in one of my previous slides: financial services, government, health or medical, and legal or the military. You can avoid decrypting all those categories. And make sure that you are considering common URL categories for the decryption, which are the online storage and the backup, peer-to-peer, all the proxies, validations, social networking, web-based email, computer internet information, any unknown traffic. So what are the best practices for the SSL decryptions? So we have all this in our tech doc section for the Prisma Access. You will find that as best practices for SSL decryption, a complete document which follows you all of these three or 1 to 5 steps in a very detailed. I would highly recommend you to please go through that document, which is the best practice for the SSL decryption. And I will summarize here each steps involved here. Distribute the certificate. The first one is the distribution of certificates. The forward trust subordinates a certificate of each of the Prisma Access deployments need to be trusted. If there is an enterprise PKI, have the enterprise certificates. If there is no enterprise PKI, then generate a root certificate. SSL forward proxy, block all expired certificates. If there is any, block any unsupported versions, configure the decryption policy rules, add sites, SSL decryption exclusion list, and also block the UDP, internet, and the quick protocol.